So we may be streaming, maybe. Let's see here. I'm new to this, and welcome if you're the first one to see this. Now where are we hiding here? Live. Oh, nothing but basic. And you should be seeing. We may be streaming, maybe. Let's see here. I'm new to this, and welcome if you're the first one to see this. Now we're right. Sorry for the little delay there. Tonight we will be working on trying to get, where are we hiding here? Basic, well, Microsoft Basic for the 6502, the OSI version, running on a 6502C computer. It has 2K of RAM, I think, and 2K of ROM. It is not the Bravo one you see here. This is pulled from another from a GitHub site, but it is a modification of a modification. So we're just going to ignore a few things, and it's not for retail or resale, so we're good to go from there. I will be compiling it using a web browser, and I can probably bring that up if I add another capture, window capture. No, not that one, and that one there. That one there is the one we'll be using, asm80.com, and then just going through a EEPROM programmer and plugging the EEPROM into the board. Right. The other thing is, well, I've got you here, and I will go get rid of that one. We've also got the that's not what I wanted. That one. This is a small demonstration of what I've got for the 6502. So it's using the external mon at the moment, but when we're doing the basic, I'll take the extended monitor out of it and run the basic one. But let's see if it works. I know sometimes it doesn't work too well, and sometimes it does work really, really well. The other thing is we can, I think I've got rid of that file. If I go back here, I've got to remember to change it over for you guys as well. Back to this one here. And we can have a quick look at the FDC stuff that I've been doing. That's saying it, cancel, control, save. Nope, wrong one. Save file as save. The FDC stuff, so this is just the FDC file, floppy disk controller that I've been working on with it. At the moment it is working okay. It is using the 82077. I can get the drive to spin up, which is pretty cool. No DMA though, so it's going to be POLT IO. I'm going to go through the data sheet to read that. That is the hex code, and this is one of the best things I can do with this hex code. And that is, where's Putty? Let's bring you guys up for Putty. Man, there's a lot of clicking. If I go L, I can transfer Intel hex code. And that probably didn't work. Okay, I normally can transfer the hex code. It doesn't copy well from the website, and we start off at 50. So this is the code that should be seen at 50. So 48 A9 OC. Actually, you guys didn't see that. Bear with me, I'm new to this. Where are we hiding? So this is the code we should be seeing is 48 A9 0C, 8D, etc. starting off at address 50. And if I bring up that one, and go to that one, 50.5F, it brings up that code that we saw before. I haven't got the floppy disk controller connected at the moment, so we cannot really go through that, because that would normally reside at 2, 3. No, it's not. It's 2F. Oh, I should know this. 30 to 23. Yeah. It's wrong anyway. It resides at the same, roughly the same address as you would on a PC, but it's shifted up to the instead of being 3. That's a 2F30 instead of lockdown. We can reset it quite easily. All right, we're not working on that. We're working on the basic at the moment. So get rid of that, and we're into the basic side of things. So what do we need to do to do the basic? So control C call, load save calls, RAM start. So we can leave that exactly where it is, and then this here needs to be changed. I'm not going to worry about the fifth one. I'm not going to worry about the sixth one. Oops, chat's in the wrong place. I just had an idea. I don't like the idea. I don't think I've got any viewers. It's in the wrong place. That's fine, I'm good. Alright. Where were we? Alright. I'm trying to find the page I want. There we go. Alright. And we should be still on that. Cool. So 0 page starts. I'm not sure what half of these addresses are for. I know 0 page starts at 00 up to 100. So user variables go through here. Stack top starts there. And RAM start, we're good for RAM. The stack start, of course, starts there. Restart, simple buffer. Now the reason why I'm using Notepad is that I can do not control paste, search replace when I do go to compile it. And I'm not sure what diffs are. The other thing is I could just bang this into the compiler I've got and get it to compile that way as well, which we might just do instead of going through the website. Let's go all the way to the base where the good stuff is. So reset vectors, non-maskable reset, and IRQ. There's another one under here as well. So start message, cold, warm starts. The other thing is I'm looking for, so serial output, TX ready, compare TX ready. We know what that is. Monitor read key. resets. So that's the reset handler, which goes all the way down the bottom, but it's up here. Okay. Wait for key press. Warm starts. Reset. Yeah, there's the Omen Bravo that it's supposed to be working on, but it is originally for the written by Microsoft for the what is it called, Challenger, OSI Challenger. I might actually have to start from the OSI Challenger, but let's see here. It's just trying to figure out where I add my code. Set interrupts, clear direction, or clear. I can't remember what that one is. I'll have to look it up. Step top. Okay, so this is possibly for control and data, command and control. Alright, this is for the serial port here. And he's also got the ACI. We're not using the ACI, so excuse me. We can probably get away with that. Okay, cool. So let's make a start. This is the serial initialization. So this is the serial port here. Command to data. Now for what we'll do is we'll do this. Control save. I am going to go to another page which you can't see, and it is not for that, it is serial test. No, I've broken my serial test code. Okay, so what we're going to do, copy, Control Z, copy, and then we bring it over here, paste. We are not using a 6502 or terminal, but it's serial port. Alright, so this is the 6502, it's not the 6502, it is the 8251. So the serial ports are our serial data, serial command, reset mode, data command, receiver ready. Okay, so this is, instead of here, what we'll do is go that, because that other bit is for the stack, and it falls through here. So this is where we do our serial command loading, and okay, so Control V. Now, if I were to do a couple of changes to that code at the top there, after we get rid of all this, so SEI is, let's see here, SCI is disable interrupts, and CLD is clear decimal. So if I do this, I got sidetracked. Crap. CLD. Clear decimal, clear interrupts. Alright, that is going to prevent any interrupt signal from interfering with the basic, with the program at the moment. That there. Oh, I dropped the mic. Well, that was very unprofessional. I dropped the mic. So these 1, 2, 3, 4 is exactly how the WOS monitor starts up, and then through here, this is what I have for the WOS monitor as well. Till we get to the last one, which is your which then falls through to the display message. So at the moment, if this was to compile, it probably work to a certain point, and this where it won't display the startup message because it doesn't know how to do it. But the 8259 will be initialized. Alright, so this is show start message, load accumulator, the start message, offset of the Y, and so Y's here. So this is going through each character and printing each character until it gets to a 0 or a wait key press. Alright, and then convert to uppercase. Serial out wait. Okay, so this one here, we can literally change. So what is SSR? Okay, SDR and SSR. So look out for SDR and SSR. Alright, so SSAR and SDR. Okay, so not quite sure what they're doing here, but for us it's going to be serial data and serial command. No, serial data, serial command, and then RX ready. So it's serial data. Ooh, it's not. It's RX ready. We never did RX ready for this. Our TX ready is always out. Okay, so push accumulator onto the stack. Pluck. I don't know why it's pluck accumulator from the stack. Store array into serial data. And return. We'll just comment these ones out for it and see what happens. Monitor ready key. So this is again serial data. RX ready. Is mine RX ready or is it RDY? Okay, mine's RX ready. different way to do it. And then serial data. Okay, monitor is Control C. There is nothing there. Start message. Okay, so that should work. Right, let's try and pull the there. What can you guys see? You guys can see that one there. Okay, so that's the bin file. Okay, that's not what I wanted. It's an emulator. Just seeing how the Bravo is compiled. Oops, excuse me. And just go through the PDF. Wow. The 6551 is a ACI with a serial port. Assembly and alright, plan B, and let's see. Nope, that's not on that one. Nope, it's not on that one. What I'm doing is trying to figure out where I've placed the build file. I don't even know how long this has been. 22 minutes. Okay, so where's the build file? How did I build this? Okay, I'm going to go to the desktop. Okay, let's just GitHub complaining, and there it is, Apple clone, ewas, and make.bat. Okay, so you guys should see make.bat. This is where are we saving it to? Control the source. Cool. Okay, let's try not use a config file, and I don't know if it's going to do, I don't know what we're doing the label for anyway. We'll move, that's off, that's out, and that's the chip I want to use. And we got a control file, save as, where we hiding, cancel, let's do this. bat, and then we go to cool. Right, there's a few errors, and well and truly a few errors. Dot size, dot reset. Okay, so this is not compiled with A86. What is it? CA86, CA65. Crap. I thought it was. Have I done something wrong here? Ah, you know what? I got rid of it at the start. That could have been it. Okay, so let's go back one and go find out what that was. Okay, it was just Engine Bravo. Okay, let's see here. I know. Wasn't EWAS? It might have been EWAS. Okay, it was EWAS. Okay. Because that's the other thing, we didn't find an origin here, did we? Next. Yeah, so that's origin 0, 0. There we go. We've actually got to change that too, because that's the C where we start off. No, is it C? Bear with me. I go back to that one. And we go to Wasmon. E00. Oh, it starts at the same place. Cool. Right. So in reality, all we need to do is to start at the same place, but change the code for initializing the 6502 and printing out. And if it's as simple as that, which would be good if it was, but it's not, because I'm getting unexpected errors. Make file. You know, I did remove the config file as well, but I'm not worried about that unless that's part of it. I don't think I saw anything in the, what have I done, in the error file. Let's try this again. Desktop. Okay, so we can only go up to that one there. Right, so let's see, damn it. That's not what I wanted. Okay, so let's see. Just go into this one here, pipe redirection. Command output. Okay, so two. Let's try this again. Okay, that may have our error messages now. Okay, so 49 expected. Okay. It's still going to give us the same problem if I do that. Yeah, expected comma. Okay, so equate. Alright, you're going to be watching me do all this. This will everything. CA65 EQU. Okay, dot define. We're going to cheat. So first one, dot define EQU equal. Okay, so that will give us that. And then back to 49, and it's lowercase as well. Can we do two of them? Actually, if we just do the one, because we're only using the... Okay, so that's that, the macro for that. Let's see if we get some compilation. And yes, 84 error, comma expected. Okay, so what's 84? 84 diffs. Control copy, control find. And backwards direction. And we may not find out what diffs are, which means that I may have lost the mic again for a little bit. Okay, so page table, we'll copy that. And we'll have a look. So what we'll do is cool. Okay, page table. And we're back to where I was before. Ay caramba! Which gives me, man, this is terrible. I'll show you what I've done before. This, where are we hiding? He was Apple clone. Okay. And I'll just add another capture window. So this, what you're seeing here is basically the same as, not the same as what we've been working on. It is the spread out version of what we've been working on. However, let's go through this here. You've got a lot of extra in here. So the things like the AM65, the Apple II, CBM, you've got the Kim down the bottom here, the MA65, that's my one that I've been trying to work on before I've been doing this, the Microtan, OSI as well, and I've been trying to get this to compile for what I've got. Okay, that's nothing in there. And these are the compiled ones as well. And for the OSI, let's have a look here. So these are the defines for the OSI. So, oh wait, I've got to bring up that page. Which one is it? Oh, that's not that one. That's not that one either. Not that one. This one here, right? Where are we? So these are the defines for like 0 pages and user page and memory start, RAM start, monitor functions as well. And this is if you're using another ROM for your project. So it looks like I might have to come back when I've made the ROM board, the additional ROM board, save a little bit of RAM, and do another live video. And do we have anybody here that's live? No, no one else is watching. Probably a boring video anyway, but it's a start. Alright, we'll see you later.